Hi everyone, Dankman here. So today is entirely review, and just like yesterday, and I'm going to go over two introductory problems that are just about looking at the general techniques that we started at the beginning of the semester, I think it was. This area model, I'll look at these two problems and then I'll do one more example, and that's what this video will be about. Okay? And this video is the first topic in our new chapter on quadratic equations and expressions, Unit 5, okay? And we're going to look at these two examples here. So multiplying 3 times this whole group, x plus 4 with parentheses, and multiplying 2 times this whole group, multiplying one group times another group, okay? So, to review, we're going to try and multiply this number 3 times this whole expression x plus 4. And it's in parentheses, which means we're not just multiplying 3 by x, and we're not just multiplying 3 by 4, we're multiplying 3 by the entire group, x plus 4. So if you remember our little algebra tiles, if I have a tile that's 1 unit tall and x units across, its area, this purple tile's area, is x square units. Okay? And so this tile pile in purple is 3 units tall and x units across, so its whole area is 3 times x. If I have this whole area in purple is 3x, and each one of these blue tiles is 1 unit, then this area total altogether is 3x plus 4. That's 3 times x, and then add the 4 separately. If, however, I wanted to take a pile that's x units plus another 4 units, and I wanted to times this pile by 3, that would mean that I have to have 3 x's and 3 4's all together. So the total area of this pile would be 3 times the group x plus 4, giving me 3 x's and 3 4's all together. And that's the difference between just multiplying 3 times x and then adding 4 versus multiplying 3 times the entire pile x plus 4. So let's examine here. One way to represent 3 times the group x plus 4 is to think about a rectangle that's, say, 3 units tall, and then moving across, its width would be x and then another 4 units. So the whole width is x plus 4 units across. Okay? And that could help us to split this rectangle into 2 pieces. And if I wanted to multiply 3 times the group x plus 4, that would give me the entire area, 3 tall and x plus 4 units across. And to multiply this out, or distribute that 3, I could think about, hey, first multiply 3 times the x to get the rectangle on the right, then multiply 3 times 4 to get the rectangle on the left. 3 times 4 is 12, and the total area of the whole rectangle would be the left rectangle, 3x, plus the right rectangle, 12. So the total area could also be 3x plus 12. And I know some folks like to write an arrow to represent, hey, multiply 3 times x, okay, multiply 3 times x, that gives you the first part of the expression, and then multiply 3 times 4, that gives you the second part of the expression. So when we're multiplying with parentheses or multiplying groups together, we've got to be careful. Okay? Now, in the case where we multiply 2 groups together, we could have one piece represented by x plus 4 be the length. Okay, that's one group. And that, or you call it the height. One side length could be x plus 4 units total. And then going across, we could have x plus 6 units total. Okay, and so for instance, going up, one chunk of that height could be x units tall, and then the other chunk could be 4 units tall. All right, and this chunk could be x units tall, and then the next portion of that length could be 6 units tall. Okay, and if we want to find the total area of this entire shape, and then we would take x plus 4, which is one side length, times x plus 6, which is the other side length. And if we want to somehow expand or multiply out this problem, then we're going to use the distributive property again, but we're going to use the distributive property in a very clever way. Okay, we're going to start up here with this x at the top on the left, and we're going to take that x and we're going to do the distributive property with that x first. Okay, so first we're going to do the distributive property with the first piece, multiplying x times x and x times 6. And in the rectangle, that means we're going to get this top left rectangle first, x times x. And then we're going to get the next rectangle, x times 6. Okay? And then we're going to add all of that together and also these bottom two rectangles together. So I'm going to keep track of what I'm adding. So x times x gave me this part right here. And then I'm adding the next section right here, x times 6. And this is all review, folks, okay? Next, I'm going to take this number 4 down here, and I'm going to go ahead and fill in these two squares, or these two rectangles, 4 times x and 4 times 6. And that's like up here, if you like your little arrows, that's 4 times x and then 4 times 6. Okay, so the distributive property again. So 4 times x gives me this chunk right here, and I'll add that on to my total area that I'm keeping track of so far. And then, to get this last rectangle, it's 4 tall and 6 across. 4 times 6 goes in here. And I'll add that on, 4 times 6. And now we just have to clean the whole thing up. So x by x is x to the second power. X times 6 is 6x. 4 times x can be written as 4x. And 4 times 6 is 24. And we're almost there, but you'll notice the middle section has two like terms, and we should combine them, add them together to get 10x. And so we turn this multiplication problem, the group x plus 4 times the group x plus 6, into this final sum of three pieces, x squared plus 10x plus 24. And you guys hopefully remember our little pattern where we had an x game, and in the top we would have a number, and in the bottom we'd have a number, and we were looking for the two numbers on the side that multiply to 24 and add to 10. Okay, and you'll notice the two numbers that multiply to 24 and add to 10 are 6 and 4. So here we have multiply to 24 and add to 10. The two numbers that did that are 6 and 4, and those numbers show up here. So that's really fun. Okay. This is an overview of just how the mechanics of how to multiply with parentheses involved, how to multiply groups. And I'm going to do 2 more examples in this video relatively quickly with some negative signs, and then you're off to your practice assignments. So, I said 2 examples. I should have said 3. This first example is 4 times the group x minus 7. I can still think of it as a rectangle that's 4 units tall. And now, though, I've got the length across is x, and then this section will be represented by negative 7. So I'm going to get 4 times x for the left-hand rectangle, and then I'm going to get 4 times negative 7 for that right-hand rectangle. So this 7 is like a negative algebra tile. Okay? So I get 4 times x, and then 4 times negative 7. And that's 4x. And then 4 times 7 is 28. And it's a negative, so it's a negative 28. So I'll call it 4x minus 28. Okay. In example number 2, we've got a height of negative 3 and a length of x plus 5. So the entire thing, whenever I'm multiplying this 3, it'll be a negative 3 times x and a negative 3 times 5. Okay, so it's negative 3x plus negative 3 times 5. That's negative 3x plus a negative 15, and so we'll call it minus 15. Okay. Next is x plus 4 times x minus 6. All right. I'm not even going to draw the model this time, I'm going to think, okay, first I'll distribute this x times x, and x times a negative 6. So this negative sign right here is what I'm going to try and be very careful about. So the red x multiplies x times x, and then x times negative 6. All right? And then I'll go ahead and distribute that 4, and that's 4 times x, and then 4 times a negative 6. So simplifying, I get x squared plus negative 6x plus 4x plus negative 24. Okay, and then I'm going to clean this all up. All right, so x squared, x times negative 6 is negative 6x, 4x, and 4 times negative 6 is negative 24. Now I want to check for like terms, and in the middle I have these two like terms. I have a negative 6x and a positive 4x. Okay, so that's going to combine to negative 2x. So I'll have x squared at the front, minus 2x, and then this plus a negative 24, I'm going to simplify into minus 24. Okay? So that's x plus 4 times x minus 6 became x squared minus 2x minus 24. And these are the three examples. On to your practice assignments.